Klipper firmware grants our 3D printers some amazing features, including lightning-fast print speeds. But if you aren't performing the necessary calibrations, like pressure advance, it's possible you're not extruding the correct amount of material while you're printing. That can result in bulging corners, gaps between lines, and overall bad prints. So today's video is going to cover what I consider an essential printer calibration, pressure advance. And here we go. Folks, welcome to the channel. I am Leo of Prince Leo 3D. Thank you so much for joining me on what is yet another Klipper-related 3D printing video. Today's video is on pressure advance, and I'm looking to answer three general questions. What is pressure advance? How does it work? And how do we calibrate it? What is pressure advance? Pressure advance is a calibration to equalize the flow of filament along an extrusion pathway. Does that make sense? If not, great, because my plan is to tell you that, explain to you what it is, and then tell you it again, and hopefully by the end, it makes a lot more sense. What pressure advance is looking to do is simulate the correct pressure throughout the entire extrusion pathway. That means at the beginning of a line, our 3D printer will advance filament in order to simulate the pressure that needs to be there. And then at the end of lines, it will retract filament again to simulate the correct pressure. What that's trying to do is equalize the flow of filament from the beginning of a pathway to the end of a pathway, so we get a line or a pathway that has the uniformed amount of filament laid down throughout. So how does it work? To understand that, we need to understand what is happening in our nozzle while we are printing. Here we're looking at a picture of our hot end with the fan shroud removed. The blue piece at top is a PTFE tubing, the red portion is the heat sink, and the bottom two gold portions are the heat block and the nozzle respectively. As we know, filament enters the hot end from the top, and then the heat block and the nozzle heat up and extrude that filament. And for that filament to extrude, pressure needs to build up in our nozzle to equalize the flow of filament as it exits. And the general math behind how this works is that 1 cubic millimeter of filament entering the nozzle is going to leave the nozzle. However, with Klipper and our fast accelerations and print speeds, that's not always the case. Let's take a look at this lines pressure advance test so I can show you a little further. Here we have a series of printed lines that are testing different pressure advances. The first portion of this line is printed at a slow printing speed. Then the middle section is printed at a faster printing speed, which means our print head and our extruder will need to accelerate to get up to speed. Finally, the last portion of the line is printed again at a slow printing speed, which means at the end of that fast section, the extruder needs to slow down again or decelerate to accommodate for that slower speed at the end. To the right of the lines are the different pressure advance values. The bottom one is 0, and that's what a line looks like with no pressure advance being used. And I want to take a closer look at that. This is a straight extruded line. It should be consistent from the beginning to the end, but you can see that is not the case. If we were to take samples at different cross sections of this line, you'll see it is being under extruded or over extruded at different locations. The first section here is the beginning of our acceleration, and it is under extruded. That is because pressure has not built up properly in our nozzle to keep up with the flow of filament that is exiting it. Towards the middle, it equalizes and we get the correct flow of filament, or a more accurate flow of filament. And then at the end, when the extruder needs to decelerate, there is a blob or an obvious over extrusion. That is because there is too much pressure built up in our nozzle and too much filament is getting extruded out. That is the problem with the 1 cubic millimeter in to 1 cubic millimeter out formula. It doesn't accommodate for certain physics. As we see in Poiseuille's law or in Hooke's law, we need to consider three basic things: pressure, flow, and the different properties of filament that can contribute to those. But when we use pressure advance, we are trying to harness those physics and help get an evenly extruded line. Let's go back to this lines test. Let's take a look at some lines that are using pressure advance. This line is much more evenly distributed from the beginning to the end. It's using pressure advance to simulate the correct pressure that needs to be in the nozzle during acceleration and then needs to be weaned off at the end of acceleration or at the deceleration. And using that pressure advance, we achieve a more evenly extruded line. Now it's important to note, pressure advance will not extrude any more or any less material. It's just evening out where that material is deposited so that we get a line or an extrusion pathway that is uniform from beginning to end. When should we do this? Well, if we were NASA engineers, we would literally calibrate pressure advance for every single spool of filament that we introduce to our 3D printer. However, we normally don't have that time. I know I don't have that time. So what I do, and what most people I've talked to do, is calibrate pressure advance per material type. That means I'm going to calibrate it for PLA, for PETG, for ABS, for TPU, so on and so forth. I'll likely have a different calibration for each of those, and I will plug those in when I'm printing those materials. Now, if I'm printing a unique material of one of those types, I will then recalibrate for that. So for instance, if I notice that my silk PLAs are printing at a higher temperature or just printing differently than my normal PLA, I will go ahead and calibrate pressure advance for those silk PLAs, and then I would use that number for those materials. When should we recalibrate for any given material? Well, if you change any part of your extrusion system, your extruder, your hot end, your nozzle, if all of a sudden you start printing at higher than normal temperatures, if you were printing at 210 Celsius, now all of a sudden you find you want to start printing at 225 Celsius, maybe you're getting better flow from that. At that point, you want to readjust your pressure advance. So again, what is pressure advance? It's attempting to equalize the flow of filament along an entire extrusion path. How does it do that? By simulating the correct pressure. It does that realistically by advancing filament at the beginning of a line and retracting filament at the end of a line. So how do we actually go about calibrating? Well, there's three methods I know of. The first method I know of, though, is using a 3D printed calibration cube. Now, this is directly from the Klipper documentation. There's a model you can download. It's a hollow cube. There's some parameters you need to set up for your slicer. And then before you print it, you're going to go into your console of your front end. You're going to copy and paste a few lines. And what those do is while that cube is printing, it adjusts pressure advance for every different layer. When that model is finished, take it off your build plate. You're going to use calipers to measure the bottom to the top of where you think the best layer is. Once you figure out the distance, there's an equation you plug all that into, and then it will give you your calculated pressure advance. Not a bad method, but it is the one that requires the most time, the most filament, and for you to own calipers. The second is Ellis's pressure advance website. Ellis, if you've not heard of them, has their own website. It's like the de facto information guide on calibrating your Klipper printers. Ellis has come up with their own pressure advance test. It's supposed to be a level above the lines test, which is what we're going over today. What Ellis has you do is go to a website, you're going to plug in information about your 3D printer, and then it's going to print a series of almost arrowheads, 90-degree turns, which is perfect for pressure advance because that's what we want to see it. We mostly see it on the corners of our model, and that's kind of what that test is utilizing. After that test is complete, you look at the different pressure advance numbers next to each set of 90-degree lines, and you find out which one is the best, and that's your pressure advance. For whatever reason, I cannot visually tell which one is the best on Ellis's testing. I'm going to use it more. I'm going to hopefully get better at it because I think it's probably a more complete test. But right now, I just don't use it because I can't use it well. So I use the lines method. Now, I think this is the most intuitive and the simplest way to go about pressure advance. Once you see how we do it today, you're going to be like, why haven't I been doing this forever? And you'll find that recalibrating pressure advance is really simple. We go to a website, we're going to plug in information about our 3D printer, nozzle side, acceleration, speed, so on and so forth. It's going to print a series of lines at different pressure advances. And all we do is look at which line looks the most complete or the most uniform from beginning to end. That's my favorite way to go about it. It's so simple. It's really easy. Requires a low amount of filament, low amount of time, low amount of material, low amount of brain power because I don't have a lot going on. So I think it's the best. That's why I think it's the best. So without further ado, let's get in depth on the method I use, the lines method of calibrating our pressure advance. We are at the beginning of our lines method of testing pressure advance, and that starts with this web page. This is a three-part test, or there are three phases to this test. The first is setting up the pressure advance test using this web page. The second step, or the second phase, is printing the actual model, and the third phase is interpreting those results. Now, the first and the third phase, we are going to be actively participating in. The second phase of printing, we do nothing. That's the easiest one, and that's what we like. The first thing we do is navigate to the pressure advance web page or the website. I'm not sure who's hosting it. I'm assuming it's Real Deuce. Whomever is hosting it, whoever created it, I thank you so much. I would love to give you proper attribution, but I just don't have any sight of that anywhere. What we're going to do on this webpage is fill in information about our printer, attributes of our printer. It's going to cut a G-code file of various lines using various pressure advances, and then from there, we are going to query those lines with our eyeballs. Weird way of saying we're going to look at those lines and see which pressure advance is best for us. So starting at the top, we have printer name and filament name. These are completely arbitrary. They don't do anything to the actual file. You can fill them out if you want. I never do. Filament diameter. The most common diameter for filament nowadays is 1.75. Make sure you get this right. I'm assuming yours is probably going to be that. Double check your filament diameter and enter it here. Now we start getting to the important parts. Nozzle diameter. This needs to be the actual nozzle diameter you're using because line size, line width, things like that are based off that in this web page or on this web page. So this needs to be accurate. On my printer, I'm using a 0.6 millimeter nozzle, so I make that amendment there. Under that, start G-code. This is also an extremely important part because if this is not correct, you could damage your 3D printer possibly beyond repair. I doubt that, but you never know. At minimum, you could at least crash into the bed and cause some scoring or scarring on your bed sheet. I'm going to take this line by line so we're all on the same page. Starting at the top, this first line here, M112. This is really just a sanity check. If you were to try and run this start G-code with that line, it would kick an error. If you want to go to this website, you'll see exactly what I'm talking about. A sanity check. It's meant to be deleted, so we get rid of it. The next two lines here are very important. Because we are not getting a G-code directly from a slicer, we don't have a slicer that's going to send temperature commands. These two lines are those temperature commands that need to be sent to our printer. The top one is the bed temperature, and the second one below that is the nozzle temperature. So I'm using PLA, so I'm going to input my normal temperatures that I use for those materials. And for me, that's 60 degrees Celsius for the bed, and this is going to be degrees in Celsius. And for the nozzle, on this particular machine, I run it at 215 degrees Celsius. So double check, make sure you have these entered and make sure they are accurate. They are currently set or they are defaulted at ABS profile numbers. They are higher temperatures for ABS. If you are not printing ABS, make sure you make amendments to these lines. All these next lines below that, these are lines that are going to be likely contained within your start G-code macro. If you don't know what a start G-code macro is, go to my website. I have some example ones as well as an explanation. But basically, the start G-code macro is a word, usually print start or start print right here, that is going to get read by your printer, and then it's going to activate the commands that are contained within your start print macro. G28 is homing all our axes. G32 is tramming our gantry. Then absolute positioning, lifting the Z, and then creating a bed mesh. All of those should be handled already in your start G-code. So what I do is delete those entirely. I do not want them in there. And then the final command we have, I'm going to get rid of everything after the semicolon, is print start. This is calling our start print macro, which should perform all the necessary pre-printing procedures. For me, it's homing my axes, printing a prime line, getting the absolute positioning, stuff like that. The one thing that is not contained in my print start are the temperatures of our bed and hot end, and those need to be called. And they are, again, right here at top, so make sure you double check these are correct. Any problems, leave them in the comments or come to the Discord. Plenty of smart people there that are willing to help you if you want to make sure, because this is of utmost importance. You don't want to mess this up. Before we go outside of the start G-code, you also want to make sure that the start print macro or the print start macro is labeled correct. For the default here, that's not what I use. I actually use start_print. So I have to make that amendment to make sure that it's going to be called properly. After I've tidied up the start G-code, I head down to the end G-code, and this is much simpler. We don't have to worry about any temperature commands. Those are all going to be turned off within your print end macro, but just make sure that the spelling is correct. And again, for me, I have the word end first, so I have end_print as my end print macro, so I make sure to make that adjustment. Below this, the rest of these lines are usually stuff you can grab directly from your slicer if you have issues with it. We're going to start with retraction distance. Whatever your current retraction distance is for your printer. The printer I'm using is a Bowden style printer, and I'm currently using a 1.0 retraction distance. So I add that in here. Now for layer height, you want to use whatever layer height you currently are printing at or you are predominantly printing at. I'm printing with a 0.6 nozzle, and I predominantly print at 0.2 millimeters. So that's what I'm going to put as my layer height. Below that, fan speed. You can leave this at 0. We don't have to worry about fan speed whatsoever. This is a single layer print. We don't need any fans. Going to the print bed section. we need to know the bed size or the printable bed size in the X and the Y directions. This is here to make sure that the printed model is maintained within your actual build surface. I'm running this on an Ender 3. The build size is somewhere around 225 by 225, but I shrink those in just a little bit to make sure that I'm nowhere near the edges, just in case this print gets large. Below that speed, this is all stuff you likely are going to be able to find again in your slicer. So let's start right at the top. Make sure you have the millimeters per second checked off. Slow printing speed can be left at default at 5. Now fast printing speed. Whatever your outside wall speed is set to. Now in slicers, you can set different speeds for different portions of your model. We are setting this to whatever our outside wall speed is going to be. Currently, I am printing at 100 millimeters per second for my outside printing speed, so that's what I set this to. If you're printing at a higher value, 130 millimeters per second, like my Aquila does, you would set it to that. Whatever the printing speed for your outer walls is, because that's what we care about, what the outer walls look like, so that's what we want to test for. Again, I'm going to go back to 100, which is what I'm using on the current printer we are testing for. Movement speed, this can be kept at the default 500. The retract speed and the unretract speed, these are found in your slicer. In general, they're going to be between 30 to 40 millimeters per second. So if you have to, make the adjustments right now. Acceleration, here's an important one. Currently set at 3000. That's the default acceleration for most 3D printers using Klipper, and that can be found in your printer.cfg. However, if you've done some acceleration tuning, maybe you're printing at a higher acceleration or lower acceleration, you're going to likely want to adjust this. And just like we did for our fast printing speed, we want to make this whatever our acceleration speed is for our outside walls. Do you not know what that is? That's fine. Let me give you an example. I'll go to my slicer. And certain slicers give you the ability, under this speed portion, this is Orca Slicer, under the speed portion, I have a tab called acceleration. This section right here. And you'll see my normal printing acceleration is set to 3000, which is what it is in my actual printer.cfg. However, my outer wall has been slowed down because in general, we want those outer walls to look the most pristine because that's what our eye catches, the outside. So I've lowered my outer wall acceleration to 2000. So that's what I want to test for. I want to test for whatever my outside wall is. So I can go back to our Pressure Advance webpage and I can set my acceleration to exactly what my outer wall is going to be, 2000. And again, if you've done some tuning of this, some testing, you can make the adjustments as you feel necessary. If you don't know what's going on, you're completely confused, you can leave it at the default 3000. In general, most 3D printers are capable of handling that. However, if you're really worried about this, contact me through YouTube or again, go to the Discord and we can make sure you're on the correct path. On to the next section labeled pattern. Now the patterns are below at the bottom of this webpage. It'll give you an idea as to what these different pattern looks like. This blue line to red line to blue line is a single line, so it'll give you an idea as to what the different patterns might look like. Quite honestly, I would keep it at the standard pattern. You don't really need to start messing around. Starting value for Pressure Advance. Now on our first test, we're going to start at 0. We want to start from the bottom and we want to work our way up. For ending value for PA, Pressure Advance, and our Pressure Advance stepping, these are going to differ based on how your extruder is set up. If you have a direct style extruder, meaning the extruder is directly on top of the hot end, my Voxelite Aquila has the Corrales Bite Pro on there, which is a direct extruder. So I would set it up just like it is here. Default 0.1 for the ending value and a stepping value of 0.005. That would be perfectly fine if this is a direct extruder. And if you have that, that's how you want to start off. Now, if you're using a Bowden style extruder, like I am on this Ender 3, meaning that the cold end extruder that pushes filament is connected via a Bowden tube to the hot end, meaning they're separated, then you want to move the decimal point to the right 1 spot. So our ending value goes from 0.1 to 1.0. And our PA stepping, and this is actually a great point before we go to the stepping value. You notice that I've clicked off this box and all of a sudden I get these yellow boxes around. That means that this test will not work properly because it is out of the bounds of our bed. And that makes sense right now. I've increased the ending value and my stepping value is still very, very low. So the amount of lines that it would take to get to 1.0 is too much or is too many for my bed to handle. But don't worry, we're about to make an amendment to that, and this yellow boxes or these yellow boxes should go away. And again, now for our PA stepping, we need to move the decimal 1 point to the right. So 0.005 becomes 0.05. I click off, and now the boxes have gone away, meaning this will safely fit on our bed. What these 3 boxes here do is start our pressure advance test at 0. Our first line will have no pressure advance. Every line after that will step up 0.05 in pressure advance. So 0.05, 0.1, 0.15, 0.2, 0.25, so on and so forth until it gets to the ending value of 1.0. So we're going to get to see an entire range of pressure advance values from 0 to 1.0 in 0.05 increments. As a starting place, this is perfect. Once we get a nice line after this, we're going to come back to this section. We're going to shrink these values, and we're going to see a more extrapolated view at a narrow field of pressure advances so we can hone in on what's best for our 3D printer. Slow speed length, we can leave this at 20, perfectly fine. Fast speed length, we can leave this at 40, perfectly fine. Line spacing, defaulting to 5 is great. Print anchor frame, we want that. Printing direction, whichever you prefer, I always leave this to default. And we definitely want line numbering so we know what line is what. We don't have to count each single one. So much easier for us. Now to the last section, advanced. Nozzle to line ratio. This determines how wide our printed line is going to be in relation to our nozzle size. And this value is agnostic of whatever size your nozzle is. A value of 1.0 would mean the line width of our printed line is the same size as our diameter of our nozzle. For instance, I'm using a 0.6 millimeter nozzle. If I left this value at 1.0, my printed line would have a width of 0.6 millimeters. We want to over extrude this a little bit. So listening to the values to the right, keeping this ratio between 1.5 to 1.2 is perfect. If you're not really sure what to do, you can keep it at the default 1.2. That would be extruding a line width of 120%. In my case, it would be a line width of 0.72. But I'm going to sort of split the difference here. I'm going to keep it at a line distance of 1.1, which means I'm printing a line width of 0.66 millimeters. Z offset, you do not have to mess with that. Use firmware retract. Do not check this, even though it says right here it needs to be activated in Klipper. It does not. I will show you later. Extrusion multiplier. This is your flow. If you're using Cura, it's generally a percentage. If you're using Pursa, Orca, anything like that, it will be expressed just like this value, so you're more familiar with it. Look into your slicer, and whatever you normally print this particular material you're testing at, enter your flow variable here. This test for me here will be for PLA, and my general flow of PLA is 98%, also known as 0.98. Obviously, 100% would be 1.0. 99% would be 0.99, and I do 98%, so I do 0.98. I find that Benchy is a little lower, and then ABS is a little higher than a 0.92 for me, but everyone's experience is different. Look to your slicer, look to your experience, and find out what extrusion multiplier you want this to have. Prime nozzle. Do you want the nozzle to extrude a small prime line next to your test? I have one in my start print macro. It does a prime line at the left side of my bed, so I uncheck this. I don't need it. And the bottom 3 parameters can be left default. We don't use any of the prime stuff because I unchecked it. And the dwell time can be left at 0. You can change the file to something that makes sense to you. This is a printer named Leo for me, and I write test. Generate G-code button, and you'll see it generates an entire file of G-code here for us to print, and this will print the entirety of that test. You can see here in the G-code where the pressure advance values will be changing. Here it's 0.25. On the next line it's 0.3. After that is 0.35, so on and so forth. You can also see the retracts right here, even though it said to check for firmware retraction. It is right here. After we've generated the G-code, just like I've done here, we can go ahead and download it as a file. It can then be found wherever your files get downloaded. Mine are usually in this little file explorer. So now I can go into my front end, upload this print, and begin. And now we need to run the test. I'm at the front end of my 3D printer that's using Klipper. I click this upload and print button. It allows me to find the print file that I want to upload and print. And it's right here. I double click it and the print begins. Now we're going to want to watch it while it prints just to make sure everything is going okay. These lines are thin and the numbering next to those lines is also very thin. So we want to make sure it's all getting placed down properly. We're not getting any warping, lifting, or clogging. The test will begin, and if this is your first time ever running this pressure advance test, stick around, watch it, make sure all the lines are being printed properly. This test should only take about 5 minutes in total. And after it's complete, if you have a removable build plate, which makes this easy, remove the build plate and we can start looking for the most uniform line. In general, it will not be at the very bottom, and it will usually not be at the very top. Those are where the pressure advances are at their lowest and at their highest, respectively. Well, first note at the bottom, you can see severe over extrusion towards that latter half of the line. That's where the deceleration is happening. Those lines are not uniform. And then up near the top, you'll notice several lines that have no printed line whatsoever, which obviously means those are not uniform. The pressure advance is too high. Now for us, the Goldilocks range is likely between 0.2 and 0.4. And the best two lines out of that range, I would say, are 0.3 and 0.35. Now I want to run another test, and I want to check this narrower set of lines. And the reason we're doing such a wide swatch, we can very easily tell 0.2 is not going to be a very effective pressure advance, and you can sort of see that 0.4 has some loss of material towards the deceleration or the latter part of that line. But I still want to check this wide range of lines just to get a better viewpoint or a better vantage point of which ones are the best between those lines. And because we narrowed the range, we can also see more lines between them by decreasing our stepping value. I'm going to go from 0.05 to a value of 0.02. So we're going to see more pressure advance values within this given range. Venture back to the pressure advance website. And now for this, our second test, we don't need to make any other adjustments except for the starting value, the ending value, and the stepping value. I want to start at a range of 0.2. I want to end at a range of 0.4. And I want my stepping value to become 0.02. Those are the only changes need be made. We can go down to the bottom. We can change this file name because you're going to need to make it a little more accurate, something like testing 224, and then click the generate G-code button. Again, a new G-code file will be created. We download that file and we run it just as before. For the second test, I chose to use a different bed material. The only reason is during the first test, I used the black stock Ender bed sheet. That was only for visualization. It was just easier to present the lines to you on camera with that black background. However, I realized most people, myself included, only use these PEI bed sheets. So I wanted to give you at least a representation of what it would look like and how you need to visualize it on that bed sheet. So the only reason I changed bed materials was for purposes of instruction. It should have no effect on the actual test. It's just so you, the viewer, can see what these lines may look like on that gold PEI bed sheet. And now looking at the results, we can see the lower pressure advance values are still causing over extrusion. And our Goldilocks zone here is between 0.32 and 0.38. The two lines that look the best out of those, 0.34 and 0.36 for our pressure advance value. You always want to err on the side of a lower pressure advance value. So for this printer, I would choose 0.34 as the pressure advance value. That is the most uniform line, and that is what should give us the best pressure advance. Now to input our pressure advance and start using it, we head back to our front end. And from there, we find the configuration page and then enter our printer.cfg. We are looking for the extruder section, and I found it right here. Under this section, there should be a heading titled Pressure Advance. If this is your first time ever inputting it, it will not be there. You'll need to add it. So I'll make some space and I'll add the line right there. Doesn't matter where you add it, so long as it's under the extruder section. After the name Pressure Advance, we need to enter our value, and we found it to be today 0.34 for PLA. So to the right of this, I'll add a comment sign and I'll write PLA. The comment sign means that everything to the right of it will not be read by our 3D printer. It's just for my own edification. And I write PLA just so I know this pressure advance is for PLA. In order for this to take effect, I need to save and restart my firmware with that button right there. And then at the home page, I can look at the bottom of the tools section, and the pressure advance section should have been added, and it should be the pressure advance we have set up. Now, if we calibrated many materials, we can go back into configuration, printer.cfg. Under extruder, we'll find our pressure advance value, And we can start adding comments next to our pressure advance so we know which values are for what material. For instance, if I have calibrated PETG and I know that it's 0.32 for pressure advance, or ABS and I found it to be 0.42, I can add that all to the right of the comment sign. And then whenever I'm using those materials, let me add the PLA so I don't forget. Then whenever I'm printing these materials, I can sub in those values. So for instance, I could come right here and I could put 0.32 if I was to be printing in PETG. Of course, I do need to save and restart for that value to take effect. And to check that, again, I go to the home page. At the bottom of the tool section, and right here, my pressure advance is now 0.32 because I'll be printing with PETG if that's what I calculated. So that is the easiest way to carry multiple pressure advance values without doing any crazy macro things. Of course, I predominantly print PLA, so I want to make sure that my pressure advance is set to that. Save and restart so it takes, and we are good to start printing. And there we have it. We've now calibrated our pressure advance and we should be uniformly extruding filament from the beginning to the end of our line. I hope you see a big improvement from this. Now, one thing I didn't mention at the beginning of this video, what other calibrations should one other thing I didn't mention before in this video is what other calibrations should we be doing around pressure advance? So before pressure advance gets done, you need to make sure you calculate your rotation distance. After that, calculate input shaping, and then calculate pressure advance. I often find, though, input shaping is usually the last calculation that people get because you need to buy other equipment for it, an accelerometer, for instance. So oftentimes people will tune pressure advance first and then come back around and then tune input shaping. That's fine. If you do go that way, after you tune input shaping, retune pressure advance because it should be done after that. If you have any questions about pressure advance, leave them in the comments. If you have other Klipper videos you want to see, leave them in the comments, join the Discord, talk about it. We go over everything. There's so many smart people there. Go there, get some information, introduce some information, show us some of your prints. We love all that. Thank you so much if you are contributing and if you have contributed. If you haven't yet, please subscribe to my channel. There's like a 90% rate of people watching these videos that aren't subscribed. That's whatever. I suspect that's just normal, but it would be great if you subscribe because that makes me think that these videos are worthwhile and more people want to see them. I want to keep making these videos, so I want to know that people are enjoying them. So what you want, how you want it, leave it in the comments. More Klipper videos, more Marlin videos. I have a video on the Benchy Beagle Cam coming up. That's going to be a Marlin-based video. Really good product, by the way. Let me know in the comments what you want. Subscribe, ring the bell, do all those things. You know the YouTube stuff. And thank you very much for watching, if you stayed this long. And until next time, like always, boys, girls, everybody else, keep on printing.